Okay, it's 8 o'clock. We'll get started, okay? Last time we go over the two-dimensional array, and then we go through the basic two-dimensional array algorithms. Okay, so today we are going to continue the different algorithms, but we will go over it quickly, and then we'll go to the more advanced algorithms. So last week we all go over these different algorithms. And then today we are going to look at the different issues. The part two part of the chapter 17, the two-dimensional array processing. So basically, if you have a discrete function that has a function that actually has x and y and a value, you can put that into a table as well. You can put that into a metric as well. And then this is a two-dimensional discrete functional model. It's like that. Okay, so sometimes function and array you can represented in different way. Okay, the nested loop we don't go over it. For loop we don't go over it. Next one we are going to talk about column major and row major. So column major and row major. So you may have an array that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is row 0, row 1, row 2. And then this is column 0, column 1, column 2. Okay, so when you do traversal over every number, you can go this first, and then this, and then this. Okay, by doing this, we call it a row major because you go over the row first. So that we call it row major. So this is row major. Now, if you actually go over the column first, column, this column, this column, this we call it column major. So column major means you go vertically first. Okay, so you do traversal, there are two ways you can go over the array, two-dimensional arrays, either row major or column major. But the way to do traversal is more complicated than this. There are actually 8 different ways. For a two-dimensional array, there are 8 different ways to do traversal. So number one, you have 2 ways to do major, row major and column major. Okay, so let's look at this one. This one actually is a row major. So you the thinner one is go first. So actually this row first, and then this row, and then this row, and then this row, and then this row. Okay, thicker one later. So this one actually is a row major. Go over the row. So the outer loop is using the row, inner loop using column. Now we call it row major. And then your row go from small to big. Then your column also go from small to big. Then you have this different loop. Row go from small to big one. Column go from small to big one. Okay, and then this we call it row major. So you have a row major or column major. That's 2 different ways. And then your row maybe go from big to small or small to big. Your column also may go from big to small or small to big. So totally you have 2 times 2 times 2, totally 8 different ways to do traversal. So this is the first way. And then the second way right here is also row major. So your row is outside, column is inside. But your column do down counting. So your column going from big one to small one. Column don't go down counting. So basically, this one, if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one will print out 5, 4, 3, 2, 1, and then 10, 9, 8, 7, 6. So this one is do down counting on the column. But it's still row major. Okay, so this one row major, both accounting on the row and column. This one, row major, row accounting, column down counting. Okay, so totally you may have 2 times 2 times 2, totally 8 different ways to do traversal. So these are the 2 ways. Let's continue. So this next one is row major, row from big to small. So coming from the bottom to the top. Column from big to small. Okay, so this one both from big to small. This one, no, I'm sorry. This one, row from big to small, column from small to big. Okay, column from small to big. This one both from big to small. Okay, so basically there are 8 different ways to do the traversal. Here we just list down this different 8 way to do traversal. Okay, any questions so far?
No.
No. Okay, now here we do different traversal. Now let's look at a spatial traversal way. So those are very standard color major or color major traversal. You have up or down. You know, one-dimensional array is easier. One-dimensional array is just from small to big or from big to small. You have forward traversal or backward traversal. So one-dimensional array is pretty simple. This two-dimensional array traversal is more complicated. Okay, this is a 4x4 array. Two-dimensional 4x4 array. Illegal initializer for integer two-dimensional array. Okay, now let's do traversal. This one let's do the traversal like this. Let's actually do this way, go backward, go forward, go backward. So it's zigzagging traversal. Okay, let's try this one. So we got this metric and we would like to do zigzagging. So this zigzagging, we actually do this and then coming back and then this and then coming back. So the outside row number doesn't change. So you still can have for integer r equals 0, r less than and the length. So go over every row from small to big, but actually this one no problem. So row part is no problem. Now let's look at the column part. Column part, if you first line is from small to big. Second line is from big to small, and then from small to big, and then from big to small. So what we would do is actually so for the even rows, we do one thing, and then for odd row, we do another. Okay, so for even row, we will go from small to big. Okay. And then for up one, you actually would go from big to small. Oh, sorry. Okay, that's it. Then this definitely will be done. So here, for every line, you still need to change them. So here we still need to put a change line right here. So it's do that of an M. Okay. So it's 1, 2, 3, 4, 7. Wait, did I put the wrong number in there? Yeah, I put the wrong number in there. The 4 repeated. Okay, I'm sorry. So that's it. You get started from 0. Okay, so you do this one going big to big to from small to big and then big to small. So this actually is zigzagging over 0, 1, 2, 3, 4, 5, 6, 7. You actually go this way, this way. Okay. Any question? Any questions so far? Okay, so these are some techniques that you may need to use when you do programming. Okay, when you are required. So remember to whenever there are two-dimensional traversal, you need to make sure you know it's row major first or column major first. And then in the row, should you go from small to big or big to small? You need to make sure. Okay, and then combine them. You may have the zigzag, different way to do it. Next one, let's look at the partial array traversal. Partial array traversal like this one, we actually have we want to traverse over only a region of your metric. Okay. And this one is a lower triangle. Okay, the triangle on the lower part, but including the diagonal ones. Okay, so let's assume that this one we will do it on our program right here. Okay, so let's assume that we actually will do traversal this one, okay, over this lower triangle, and then the diagonal included. So it should print out 0, 4, 5, 8, 9, 10, 12, 13, 14, 15. Okay, that's the traversal that we wanted. So let's look at this one. Let's look at this one. Let's call it partial. Okay, partial traversal. So this one, let's see. You actually go from row 0 to the end. So row no change. Row still from small to big. Okay, so row by itself no change. So you do for integer row equals 0, row less than n balance. Row increase. Column you count it from 0 up to the middle, up to the diagonal part. So up to what? Up to row equals column. This diagonal is row equal column. Okay. So diagonal part is row equal column. So for integer c equal 0. C actually less than or equal to r, and then c increase. and then you extend that out that way. Yeah. Percentage 3D. Okay, this one I don't change line. Okay, this one I don't want to change line. I would just print one by one. So you know the traversal order. Okay, this is partial traversal. Okay, so it's actually this is go over 0, 4, 5, 8, 9, 10, this. Okay, is that okay so far?
Yeah.
Harry said it's okay.
Yeah.
Okay. Next one. Next one, because we do this partial array, let's look at the combination number. This one in the earlier we talked about the combination number already. Okay. But here we are going to repeat it one more time. Combinations. Combination, generation of all combinations for certain array is or a certain string is very important. So let's see. If we have a set that has the A, B, C, D, we want to pick two symbols from this set. So the possible combination will have AB, AC, AD, and then BC, BD, and then CD. So this one is C4 pick 3. 4 times 3 divided by 2 times 1, you get 6. So there are totally 6 different combinations. This one we discussed it as K-graph before. Okay, as K-graph before. Now we repeat it because it's related to this two-dimensional array. Because if you look at this one, if you look at the chart, you do have A, B, C, D versus A, B, C, D. So the diagonal, you don't pick it because this one is AA, BB. So diagonal line, you don't pick it, don't pick it, don't pick it, don't pick it. And then you want to have a combination. So the combination is an upper triangle. So upper triangle is AB, AC, AD, BC, BD, and CD. So totally this is C4 pick 3. You got 6 of them. The lower triangle is symmetric. So it's a BA, CA, CB, DA, DB, DC. So lower triangle is another C4 pick 3, but it's symmetric. So you just need one set of them. So we pick the upper triangle. Usually we just pick the upper triangle for the combination numbers. Then we can list out all of the combination numbers. So let's do it. Okay, let's do it. Let's assume that we do have a string. It is static. Okay, string set, string array. Okay, let's call it set. Okay, so this is set. We do have. Let's put in A, B, C, D. We want to get all of the combination of two simple combinations. Okay, so let's do this. Okay, so you basically you want to go over the top upper triangle. So you have 4 integer I equals 0, I less than s less minus 1. This one you only go from upper one, the last row you don't have it. Okay, you just have the 3 row, not 4 row. And then I increase. And your J starting from I plus 1. Okay, let's look at it. You want to have the upper triangle. The upper triangle, this one, your row from 0 to S the length minus 1. The last row don't have it. Okay. Column, actually, this one is I equals J. This one is J equals I plus 1. So it's starting from J equals I plus 1 to the end of the array. So to the end of the array. So you do J less than S the length. Here you don't minus 1. J increase. And then you put system type. System type. Out of the line, your S J. Okay, you combine these two together and put them out. Okay, let's look at it. So 6 of them. Okay. Any questions so far?
No.
Now, this one is a combination of 2 symbols. Now, if we change the problem, like we want to generate all of the possible 3 label combinations. So you have ABC, ABD, and then you have ACD. And then let's see, what else do you have? And then you may have BCD. So you actually do C4 pick 3, right? So you actually have 4 band over 3 band times 1 band. So actually 4 different combinations. Then how to generate this? Two symbols we can generate. So how to generate 3 symbols? This one, Kingston, do you know?
No.
How about John, do you know?
No.
Let's look at this design then. Let's look at this array again. So you do have the A, B, C, D. So the way you do it is that let's assume that you actually, the first one, I you started from the first one. So how many possible J then? Second symbol. J will have 3 possibilities. So J is the I plus 1 to the end of the length. Okay, so your I started from the A, but your I is the largest I that you can reach. Because you are picking 3 symbols. So your I can only go to A, B, C, D. You can only go to B. So your I now actually can only go A and B. J actually starting from here, from B to the end, but it not really to the end, it actually up to C only. Okay, so this one is I, then J, you can go from here to here. I, you can go, let's see, you can go here to here. Now the third symbol, let's call it K. K, okay. So if the I starting from here, J starting from, I starting from here, J starting from here, K will start from here to the end of the array. If I get started from here, J get started from here, then your K has to get started from here. Okay, so in a way, let's see, this combination we can do copy. Let's change it to combination 3. So here I just need to do one thing. This -1, change it to -2. This one, change it to -1. And then let me copy one more. And then put it over here. And then let me have it actually called K equal J plus 1. And then this one, nothing. So here, this one is K. This one, K plus plus. This one is the third level loops. We need to put a parenthesis in there, curly brace in there. And then this one is plus S in there. This one will generate all of the combination 3 combinations. So let's do this. Actually, A, B, C, D, 9, but put an E over there. So 5, so C5 pick 2, C5 pick 3. Okay, so C5 pick 2 should be 10. C5 pick 3, I think it's also 10, maybe it's actually wrong. Okay, so this one is C5 pick 2. This one is C5 pick 3. Both are 10 elements. Is that okay?
Yeah.
So remember this, okay? If you need to generate all the pick 3 combination, how about pick 4? Pick 4, you actually continue. Change to combination 4. So here is IJKL. Let's actually copy this one. And then put it over here. And then push this one in. And then put another one. So this one actually from IJKL. And the number should go from -3 to -2 to -1. This is the window size. If you look at it, this is the window size. The outer loop need to have the window size of 4, window size of 2, window size of, I'm sorry, window size of 4, 3, 2, 1. Okay, so window size of 1, you actually less than this. Window size of 2, window size. So that's actually showing you how to combine it. You may have one extra. So in a way, if in the competition, you need to generate all the possible combinations, you got to use this method. Something wrong right there. You actually 4 later, how come it's ABCC is wrong? IJKL. This one is IJK. This one is not J. It should be changed to K. This one is actually a bug right here. Okay, I forget to change it. Okay, it's okay. There are 5 different combinations of 5 different combinations for the pick 4. So here teach you how to pick 2, pick 3, pick 4, pick N, any of the C5 pick N. The algorithm is the same. It's related to this upper triangle algorithm. Okay? It's a combination numbers. And then there's another thing called permutation. Okay, permutation will wait until to generate all the permutation will wait until the recursive function. Okay, right here it may be too difficult to talk about it. Any questions so far?
No.
But in the competition, you do need to be able to generate all kind of the sample space. Okay, so this is a partial array. We cover this average. This you can look at it. Jump by 2 for each one. These are easy one. We don't know. Vector area copy. You copy from one area to the other. This one, remember the vector issue. So you go 2 by 2. You go over 2 by 2. And then your base is 0, 0, copy to 3, 3. So 3, 3 by the ij is your vector. So you go through the 2 by 2 traversal over there. So this one is area copying. Okay, need to know about area copying. And then flip, you need to be able to calculate the symmetry location. So here, how to flip the point to the opposite side of your array. This I think in the symmetric calculation we teach you already, so that we don't repeat it. And area shift. Area shift sometimes is in the game. When the game design, you need to change your background. So you originally you have this. Let's assume that you have a car right here. So instead of moving the car, sometimes you move the scene to the right. Then you feel like the car is moving to the left, but actually you use the area shift to the right for the background scene to change. This is called area shift. Okay, area shift is very similar to the swap algorithm. So let's assume look at only single one row. If you want to do shifting, you pick up your 4, then you copy from 3 to 4, 2 to 3, 0 to 1, 1 to 2, and then 0 to 1, and then temporary value back to 0. Then this row will be shifted. So you do every single row. So this inner one is every single row. Okay, inner one is every single row. You do rotation on every single row. Then it's your area shifting. Okay, let's actually look at our code. Let's go back to the traversal. So traversal so far we have here. So that's actually assuming that we are going to do shifting. Shifting to the right, so it becomes 1, 2, 3. Shifting to the left, so it actually becomes 1, 2, 3, 0, 5, 6, 7, 0. Okay, something like that. Actually, this is 4. Okay, something like that. So before we do shifting, let's actually have the printing algorithm. So let's print it first. 2-dimensional printing first. Because we always need to print metric. Okay, so that's actually let's print the M first. Before shifting, let's print it. Now next one, let's do shifting now. So let's do shifting. So this one, let's call it area shift left. So since you want to shift to the left, so let's assume that you have 1, 2, 3, 4. Shift to the left, you need to shift to 2, 3, 4, 1. So you need to pick up this one and then copy back to the tail. Okay, that's what you need to do. So for every row, okay, set up the outside loop, and then now each inner one you need to do shifting to the left. So you will do integer temp equal to n I 0. Okay, and then for integer I equals 1, I less than and n. Okay, no, this one need to be changed to j. So j less than this one n I length. Okay. You actually starting from 1, so you have 1, 2, 3, 4. You're starting from this one to the end of this one. Each one of them you need to copy here, here, here. Okay. So this is okay. And your n I j minus 1 will be equal to n I j, and then for the end, your n I n I length minus 1 should be equal to f. Okay, that's area shift to the left. Okay, that's area shift to the left. I didn't print it yet. Okay, I'm sorry. I need to print them. I forget to print them. So after the shifting, I need to print the metric one more time. I'm sorry. After shifting, I forget to print. Okay, so this one actually is shift to the left and then go back to here. It's area shifting. Okay, any questions so far?
No.
So same thing for the area shift to the right. Same things for area shift to the right. Okay. So you can copy this one for area shift to the right. This one, outer loop the same. Inner loop, you don't pick up this one. Inner loop, you pick up the last one. Okay, this time you shift to the right, so you have 1, 2, 3, 4. You pick up this one, and then shift, and then copy that. Okay. So this one you would change started from mi the length minus 2, and then you change greater equal 0, then j decrease. And every time you would j plus 1 will be equal to your this one shift to the left. Okay, and then your finally your 0 location is the temp value. Okay, so let's copy this. So right here, you originally is this one, you shift to the left, and then shift back to the right, shift back to the right, you go back to the original. Any questions so far?
No.
So these are basic two-dimensional advanced algorithms. You need to remember them, including the flipping, area copying, vector, this different thing. Okay. Now, once you are okay with this different algorithm, next one we are going to go over something more advanced. It's a two-dimensional array processing. We will look into the image processing part. Okay, so image processing, your image is two-dimensional image. You have two ways to represent your data. One is called raster-based. So raster-based image is actually using pixel. Each pixel you have RGB value to get a graph. That's called raster-based. Another one is called vector-based. Vector-based, you use a geometrical function to show people the lines and the color inside. Okay, so there are two different systems, and there is a Java, the AWT, the color. These are different color systems that you can use. Okay, anyway, these are not what we want to do. What we want to do is this example using the picture and different one. So we will look into the picture algorithm. Okay, let's go for it. So this one, I'm going to open a project that we have last year, okay? Actually, we have been using it for several years. So this one, let's see, chapter AB. Not this one, actually. Array is the array. This one, let me see, this multiplication label diamond and two. Mutual operation, not this one. Okay, I'm sorry. Now we open somewhere else. So look like last year, we do not cover the graphic part. Let's look at okay, let's put it here. Okay, so right here, there is a classical picture. Okay, this picture algorithm, I got it from Princeton University. Okay, so anyway, so there is a big library of the Java code dealing for picture. So let's copy the whole thing. Okay, it's too complicated. We cannot go over every detail for it. Let's just copy for it. Okay, just copy. So right here, let's create a new class. Let's call it picture. So we are going to use this picture class to represent the picture. So here it actually new a picture and then print picture height, whatever. Okay. This one, this is a picture. That's actually wrong. Wrong name program. This one, it doesn't have the argument. Oh, I'm sorry. So this one actually cannot be wrong. Okay, let's try different way. Okay, let's try different way. Anyway, let me close it. So right here, this one, there's a picture class, there's a grade level, there's a show picture. So let's look at this grade level program. So this grade level program, this one a little bit too complicated, not a grade level. Let's actually do show color. Okay, let's look at this show color. So this is show color. You use the color class and then open a picture and then get the width and height and then show the picture. That's it. It only get the picture and then show the width and height and show it. Okay. So this one pretty simple. But before we do it, let's get the picture. Okay, let's get the images. So the images is in the directory. So let's actually find for it. So look like last year I did not cover this example, but it's okay. Here, let's actually go to here. J, then chapter A. I'm going to get all of the image over. So let me copy the image, the whole image directory to where we are right now. So this example show you the 2D array to handle the images. And we are using the Princeton University's algorithm. So right here, chapter 18. So under the chapter 18, I'm going to post this image. Okay, so all the image is here. So this image, let's look at the image. So there are several pictures. There's a potential gray, potential color. So there's a potential color, the color image. Okay, this color image is like that. Now we are going to open this file and then show it. Okay, we are going to open this file and then show it. This is a PNG file. So anyway, we use this show color function. So let's copy this show color, the whole thing. It's a pretty simple function. And let's go back to here. So this one, let's create a new one called show color. So let's put it over here. Okay, this banner, let's actually delete them. Actually, let's just have this. So pretty simple. You just basically new image using the picture class, and that picture class can handle the picture. So you put the file name in here, and then you actually the picture object that show. That's it. Then you can show your image. So that's very simple. Let's run it. Okay, is that okay?
Yeah.
So that's pretty simple, but this one doesn't teach us much of the image processing yet. Okay. Next one, let's look at the gray level. So this gray level's job is to convert the color picture to gray level. So what they want to do is like you open the picture. No, not this, not the gray level. I mean, this one called color to gray. Let's look at the color to gray first. So this color to gray is convert the color to gray. So you get the color picture, and then you go over the column and row, and in each column and row combination, your picture get that picture, and there's a color. And then you convert by luminance that to gray. Luminance that to gray is actually based on your color to convert it to a gray color. Okay, let's look at the luminance to gray, how it convert the color to gray. So luminance class is this one. It actually is a class. And then there is a to gray function. You get a color, and that color you get a value. You use that value to actually convert it to white. So your red, green, blue, it all set to the same color level. So that is the gray color you have. Okay. And then here there is a function called lum. Lum is the luminance level function. Luminance level using your red, green, blue, and then using this formula. 0.299 times red plus 0.5787 times G. Okay, so this one actually is a pretty standard color to gray conversion. Your RGB to one color, you actually usually use this for it. Okay. So let's next. So this luminance metric is pretty openly used in image processing. Okay, so you do have the RGB vector converting from one RGB level to the other. When you do color space, you have certain RGB value. You want to convert it to different one. You use a RGB conversion vector from the input to the output. And this metric may change. Right now it's using 111. 111 means you keep the same value for the red, green, blue. But they are different color conversion spec you can use. Okay, so let's actually look at the different metrics. So here you can use RGB to YCRCB. Okay, so red, green, blue to chroma green, chroma blue, chroma red, chroma blue. It will use a metric right here. Okay, and this number will be the one that you are using. Let's look at this one. This is color matrix, okay? I'm sorry. How come we have this? No, I don't like this one. Let's just open this book by a new tab. What we want to see is this color matrix. So your color matrix, your RGB fit in here. And in your luminance level, this one. To calculate your luminance level, you see this luminance level 0.299.587.114. This three number is the one that we use right here in the luminance class. When you look at the luminance class, it is the same formula that being used to calculate the color to luminance level. Is that okay? Hello?
Yeah.
Your input is RGB. Your output is YCM CBCR. What's that? Y is luminance level. Y is overall brightness or darkness. And then CR is the chroma B, is the blue offset. CR is the chroma red, is the red color is the offset. So it use these two value combined to create a new color space called YCRCB. Okay, so YGB is used in monitor. YCBCR is used in video, in TV. Some of TV using composite video is using this one. So they do have this kind of matrix conversion. Anyway, what I want to say is this kind of color conversion is a heavy interest in matrix calculation. That's all you need to know. And let's actually copy that luminance class over. So right here, let's copy this luminance class over. So the luminance class is to provide a function to convert the color from RGB to gray level. That's all you need to know. Oh, I'm sorry, I create on the wrong one. Okay, I have the typo, but it's okay. Because the BlueJ will fix the file name. Okay, this one is luminance. Let's actually compile and get out. This one, we don't need that. Let's actually delete it. This one, let's close. Okay, now we got a luminance. And now this one, let's close it. So next one, what we would do is that let's look at this color to gray function. So color to gray function is you get a picture and each pixel you convert it from color to gray level. And then you set your new color and you can show it. So this one pretty simple. Let's copy. So go over the whole matrix, go over the whole image, and then reset your color one by one to gray level. Okay, this one's called color to gray. Now that's wrong. Okay. So the color image that we see, because we use the luminance levels calculator, and then it actually convert it to gray level now. Okay, this is image processing. So basically, what I want to say is that this 2D, two-dimensional array is used for this purpose pretty often. Okay, now let's try a different PNG file. Let's try see image file for Taipei 101. Let's try this one. Let's save. Okay, I'm going to put it into the image directory. It's a JPEG file. Okay, anyway, let's try. So here, let's see, let's actually do show color. Okay, let's use this show color. Instead of using this one, let's actually comment it out. Let me copy it. And this one, let me change it to IA101.jpg. Okay. Compile. Is that okay?
Yeah.
So that's a file that we download from internet, and then we can actually do it. Okay, so today I'm going to use this file, Hyper-101 as example now, because I want to show you that we do use it. No, let's actually look at okay, next one that we actually may convert it to the grade level as well. Okay, so we will put into the grade level, but sometimes we may want it to make it brighter or darker. So there is a brighten algorithm. So you actually put the number of brighten increase numbers. So you increase your blue, red, and green all by the brighten numbers. And then if the number greater than 255, you limit it to 255. If you go under 0, you actually will bring back to 0. So it actually limits the number within 255 and 0. But you will actually use the brightness increase number. This number sometimes is negative. So the color may go negative. So anyway, this one is to get a color and then adjust the color to different color and then return a new pixel. So you open your file. And then you actually open a new file and then go over to each pixel and then brighten each pixel. Okay, so this is what we have. So let's copy this one, grade level function. Okay. And then let's actually, this one, let's create another one. Grade level. And then let's post over here. Now I'm going to change it because the first part, this one open a file and then just to show it, we don't need that, let's actually delete them. I don't want to show the grade level anymore. Let's close them. Okay, so right here, I just want to create a picture. And this picture will based on the type A101. And then this picture, we get the pixel. We get the pixel. Oh, we actually need the original picture. So this picture 2 is needed, and picture 2 is needed, but the picture 1 is also needed because we want to copy from the picture 1 to picture 2. So let's open this one. Actually, we get the picture 1, but we don't want to show it. I don't need to show it like this one. But I actually open the picture 1 using the IA101.jpg. Okay, it's okay. Then, so I open this picture twice, picture 1 and picture 2. So from picture 1, I'm going to get every data from picture one. And then brighten it by -80. So make it darker. Make it darker. This one is make it darker. Make it darker and then set the picture two, and then eventually show picture two. Okay. So here you also need the width and height. So this width and height. Let me open the width and height as well. So width and height. Okay, let's go. Okay, so this one a little bit darkened. Now let's do this. Let's actually do -200. So make it more dark. It is way darker. I don't know. Oh, this one is color. So okay, let's do +200 then. See if it is brighter. So +200 should be very, very white. No, it's actually not changing. Something's wrong. Let me see. Oh, here it actually row column should use new pixel. Okay, it should be using new pixel, not using the pixel. Should use a new pixel, not using the old pixel. Let's try one more time. Okay, so this one very bright. +200 is very bright. Let's actually change to -200. So it actually will be very dark. Almost cannot see anything. Okay, so here let's adjust to -20. It doesn't show. I think this picture may not be a good one. Let's try different one. Okay, let's try different one. Let's try. Let's try different one. Let's try Fuji-san. Okay, let's try Fuji Mountain. This one I think is good. Let's just say this is Fuji Mountain. Well, this one is AVIF. No, we cannot handle it. Try a different one. Let's try this one. Save image. The file format we cannot handle it, so I just cannot use it. Okay, this one JPEG. Okay, so this one let's call it Fuji. The type 101, I think, have too many transparent components in the picture, so it's not good to use it. So right here, let's change it to Fuji. Okay, let's see. The picture is big. I think it's really big. Okay. So what can we do? Let's actually go to the picture is too big. Let's open it. Open with paintbrush. Let me resize it. Okay, this one too big. Too big. Let's actually do resize. And let's do edit. No, let's see this one. precise. So that's percentage. Let's change to 30% each. And let's do save. Make it smaller. Okay. So make it smaller. Now let's go back to our program. So let's run this one. Go. Now this is smaller. Okay. It's smaller now that we want to adjust the color. So let's actually do -8. Let's make it darker. I just want to show you when we do image processing, we make the color darker. It's darker, right? Actually, the picture is darker. So if you actually do +20, it will brighter. So let's do +100. Okay, so +100 is like that. Any questions so far?
Mm.
No question?
No.
So this one actually is grade level. Let's actually do mirror. Okay, I'm going to show you the image processing now. So this one, we are going to copy this one from the grade level. So we don't need a grade level. We actually, let's actually copy everything. The banner, I don't need it. I don't need a banner. Copy. Put it over here, okay? So let's put under the mirror. So the purpose is to do mirror, vertical mirror, okay? So this, let's cut this mirror to grade level. It's no longer called grade level. Delete this part. Okay, so this brighten, whatever I think is okay. We don't care about the brighten anymore. So our original picture, we read in the original picture, we call it picture 1. Get the width and height, that's no problem. Okay, and then this is show the original picture, we don't do that. Okay, so we keep this one lean. Now we have picture 2 is also open that from that. Then we go over every column and every row. So we get a pixel from certain row and column. Now we want to map to the symmetry location right here. So you keep the same row should be the same, but your column should be changed to your width -1 minus column. Okay, width -1 minus column would be your new location. So you get the color from this one. Okay, let's assume that you actually your brighten now set to 0, so you don't change the pixel. Pixel is the same. So you just don't set to the row column. You set to the width -1 minus column. So that each row and column, you copy to the location of width -1 minus column. I have a spelling error, so it's okay. Let's change it. So it's width. Now let's look at it. This is mirror. You see, the picture is left-right mirrored. Is that okay?
Yeah.
So doing the same thing, you can do vertical mirror, you can do copy from certain region to the other region, whatever. There is a picture lab, AP picture lab you can do. Okay, you can search internet and then there's an AP picture lab exercise in all kind of the picture algorithm. Here today, we just show you this mirror function. Okay, they are shrinking, making bigger, smaller, all kind of function. So today we show you one algorithm for brightness adjustment and also one for the mirror algorithm. Okay, but you can basically apply all of the technique that you learn from this whatever this chapter to the image processing. Okay, is that okay so far?
Yeah.
Yeah.
And then overall, you just need a real technical file. Is this picture.java? Okay, that's the only thing that I'm using so far. Other people's library, everything else I think is not that hard. The only this picture that library is really hard. But you just copy this one, you can do a lot of things for the pictures. Okay, that's what you need to know today. And hopefully you play around with different pictures and you can gain the knowledge for the two-dimensional image processing, okay? Image processing is very important. It's very important because your AI primarily processing on a few things. Your AI usually is looking at either text, you do translation from one language to the other. And then another AI is to do pattern recognition to recognize a person or a car, and then to do collision avoidance so that you can design your self-driving car. So image processing is the key for the AI right now. If you do video or you do image processing, okay, generating AI, they all based on this image. So this is a two-dimensional array is pretty important. Right here, we just give you the very basic introduction. Okay, so that you know that what is image processing. But image processing by itself is a class in college. Okay, image processing by itself is a class in college, and there's also image compression doing JPEG. Okay, JPEG. In the APCSP, we do mention a little bit of the JPEG before, but there's a JPEG. And nowadays, you also need to know about how to use the algorithm for AI to do pattern recognition, the age detection, all kind of things that we mentioned before. If you are interested in the picture lab, I have the picture lab code. Okay, you can get started for it. Okay, anyway, we actually go up to here for this two-dimensional array. Okay, then after that, you will go to the higher dimension array, third dimension, fourth dimension, fifth dimension to deal with the data. It's actually similar to the two-dimensional data. Any other questions so far?
No.
No? No, right here, I think this, we finished the two-dimensional array, okay? There's one thing that I did not cover yet, but we actually ignore for a period of times. That is the nested loop. Let's go over the nested loop since it's related to two-dimensional array. We kind of don't have time, so in the chapter, maybe chapter 9 or 10, we actually ignore it. Let's go to the array processing. Let's see, actually array. Loop processing. I think it's in loop processing session in chapter 9. So loop processing, we do have the nested loop. We did not cover the nested loop. Okay. So this first thing is that you want to create a multiplication table. Okay, this multiplication table is pretty simple. So let's look at this one. So you want to create a two-dimensional index space, I and J, and then you print out your data into each of the cells. And you should be able to create a multiplication table. So let's try it. This is not really hard, but we actually did not cover it at that time. Okay, you have a number called base. So you may have a base 10, base 16, base 8, different kind of multiplication table. So let's do this. Before you design the multiplication table, you do for integer I equals 0, I less than, you started from 1, so from 1 to base minus 1, so you actually, to base, so you actually from 1 to 9. Okay, from 1 to 9. Okay. So first thing is that we want to print the number from 1 to 9. It's a base 10, but actually 9 is the largest number you can have. And then we only print one line, so you get a 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's one line. But because you want to work on the multiplication table, so you need to have a line or such lines. So each one of these you do for integer j equals 1, j less than base j equals. Okay, so you got an I, and then you print in. So each time of them, you actually print out 1 to 9. So you do 9 times. Now, if you are j, you take into consideration, you can use the I and j to create 2-dimensional space. So in that case, you will generate a multiplication table. Okay. So I think that part is easy. Now, if our base is a base 16, then you will do 3s, and here you do integer string of the I and j and using the base. Okay, right now this one, if you use the base 10, that's fine. You get this. Okay, now let's actually do this. Let's do system.out of line. So this one will convert the I times j to a base number. So here, if I change it to base 16, then the multiplication table of base 16 will be generated. Okay? Is that okay? Hello?
Yeah.
Yeah. Yeah.
So I think in the homework we have a base 29 or something. You just figure it out, okay? in the homework, in the nested loop chapter, we do have a higher order multiplication table. That's okay, up to you. Here, the key point is the integer toString. Integer toString, you use a base, you will convert to the string using the base system. That's you need to know. Okay, that's what you need. So that's why I usually tell you that to convert a number to string, this is one good way to convert it, especially when you involve the base. So if you actually don't like the lowercase, you can do also do two uppercase. And then that number will all be uppercase, be look prettier. Okay, more like a multiplication table now. Okay, that's the first thing that we cover for this multiplication table. Okay, the first thing you need to know about it. Next one is that using the I and J, you will create two-dimensional space. Okay, so the indexing is very important. You see, sometimes we use the index to do combination numbers. Sometimes we use it for feeding out data. So you have to know about this different data. So now, let's assume that you want to print out these. So you have a span of 1, 2, 3, 4, 5. Span means the number of the shop. Okay, so this I is the number of the element in the line. And then this is totally print how many shop you need to have. Then you will get this pyramid print out in this way. Okay, so that's the way that you design it. So here, if you need to design something like this, you have to calculate each line before the shop, how many space need to be printed. So you print your space, number of space right here using one loop, and then print number of the shop after it. Okay, and then you should be able to print out the format that you want to print. So this one, same thing. Here, you need to calculate how many space you want to print and how many shop you want to print after space. So how many space right here, how many shop after it, okay? Okay, if you need to design something like this, then you need to cut it in this way. So right this corner, you do need to have a 3, 2, 1 space, and then print 1, 2, 3, 4. So you calculate number of space and number of shop. And this is the number of shop you need to duplicate for the second copy. You will got this part. So basically, you increase the number of the shop and then decrease the number of shop. You decrease the number of space, increase the number of space. You should be able to print out this diamond shape. Okay, that's the way you do it. We just go over quickly, okay, so that you know that what they are. Okay, the part we did not cover it, but we go over the nested loop. So this is GCD, we covered it already. Any questions so far?
No.
Any question about homework?
No.
No, okay, then our chapter 18 is up to here, okay? So before we finish, okay, we are about to finish. We have not too many chapter left for the AP level, okay? We are done with the chapter 18, so 3 more weeks to finish. Maybe 4, maybe 3, maybe 4. We would depending on how much material we cover. So we are going to cover, and so far all of the language is done. So Java is almost done. The language itself is almost done. Next one, we are going to the algorithm part. The algorithm starting, sorting, and searching, recursion. So it's all algorithm related issue. So starting from next week, we'll look into the order n problems. Okay, complexity problems, starting to look into that. So before we move on to that part, let's recap a little bit. So initially we talk about the basic operations, then loop levels, and then loop functions, and then array, and then two-dimensional array, and then array list. So basic data structure. This is the structure of the AP Computer Science A. So initially, I told you you need to finish the solo learn first. The purpose to study the solo learn is to go over the Java syntax once, making sure that you actually remember the major syntax of the Java before you go into coding bed. Okay, so solo learn's purpose is to get familiar with the language. Most of you are doing okay. Some of you really not paying enough time into it. So after the solo learn, you still forget everything. Even chapter 8, you actually cannot handle it. That's the problem. Okay, that's the problem. You write yourself. Now, next one, we go into the coding bed. So coding bed, there are level 1, 2, 3. Level 1 is pretty easy. So basically, if you finish the first few chapters, you should be able to handle level 1. And then level 2, you learn most of the program structures there. So some of you struggle in level 2 because you don't have the good habit to calculate the index. You don't come up with the algorithm by yourself. Okay, some of you copy from somewhere. That's really not good. Okay, so the purpose of having this coding bed practice is making sure that you actually learn a good habit for practicing coding. Okay, so you go over from level 1 to and then eventually to level 3. So this whole set of the coding bed is preparing you for the basic program structures. Some of you already finished it. Some of you still in the middle, still in level 2 or level 1. You need to speed up. Okay, you need to speed up. I say speed up doesn't mean that you need to jump over and then skim over another thing. No, that just means that you need to put more time into it. Otherwise, you cannot catch up. Okay, level 3 start to have some problem solving difficulty. Okay, and then passing level 3, we will allow you to do user code prompts, practice problem. At that time, the type problem would be harder, much harder. Okay, if your language is still very weak, you cannot handle it. You will get bored of it and you cannot finish it. Then you are out. Okay, your basic is out. Then nobody can help you. Okay, I don't want to help you anyway, because you are not ready. You push yourself in the wrong direction. You are not ready, so we cannot help you. So making sure that you actually have very solid foundation in the coding bed. Okay, and know the basic program structures. And then when you need to calculate the index or knowing about what is running index and which program you need to use, you must be very good about it, because in the competition, you don't have time to regrade. You have to pick the right data structure and algorithm at the same time, at the first time. Then you can save some time. If you waste your time very quickly, your time will kick away, and then you will be out. You will be out. You cannot finish. Okay, so that's why we spend so much time on coding bed. Okay, so if you are still not good at the coding bed, you still need me to tell you what to do. If you are good after the coding bed, you should not need my guidance to do coding anymore, because you know what are the basic program structure. Now the next level, you will move on to the problem solving. Okay, if you still struggle for different index, or I don't know how to do the programming, then your coding bed is really not good enough. So what you can do is get a new email account or an email account from your parents or your brothers, sisters, redo the whole thing, making sure every detail you can handle it by yourself. We do give you some guidance or some hint, but the most important part is that you need to write the program by yourself. Try not to get or to consult the solution from internet. Try not. Some of you may have done that. That actually is totally bad, because it will take away your time to practice coding. Okay, we want you to be all generic, genuine, or authentic, all by yourself. Because later, when you go into interview or everything, you need to be able to handle it by yourself. Okay, is that okay?
Yeah.
And then when you try to remember the code, draw pictures because you never remember the language. You never remember so much sentences. But if you do one picture, you will remember a lot of things, how to do symmetric swap. Picture, you use a pictorial memory. Pictorial memory, okay. Usually the pictorial memory is better than the textual memory. You will remember the algorithm better, and that's the base that you need when you move on to higher level competition, okay. So right here, you finish APCSA, next level you go to user code bronze and APCSB, that's for data collection. You also need to still continue to move on to data structure and algorithms. That's level 3. Okay, level 3 is not bronze. Level 3 usually is for gold level. Okay, so you need to keep working hard. Keep working hard. You need to have at least one language reaching the level 3 before you go to college. Otherwise you cannot do CS major. Okay, if you want to do CS major, you need to have at least one language. You are at level 3, at the data structure and algorithm level. Okay, so that's the goal. But at this moment, please help yourself to build up a very good coding habit, practicing habit every week, at least 5 to 10 hours on this. Okay, if you go to college, you have a 3 credit course. Usually you need to time 4. That means every week you need to spend at least 12 hours on it. If it's a 4 credit course, you pretty much will spend about 16 hours on it. If you go to college to take a CS course. Okay, so you need to invest enough time into the course. Otherwise, you cannot pick up the knowledge. Okay, so that's what I want to say so far, to making sure that everyone understand why you come to here to learn programming and where you are going. Are you actually go to major in CS, or are you going to major in X, or are you going to go into biomedical engineering? Whichever major you want to have, programming will help you, but you must know why you come here to study and then what do you learn from here. Okay, anyway, good night then, good luck then, bye-bye.
Bye. Thank you.
Thank
Bye-bye.
you.
Thank you.